Okay, so we've got our UDL as a point load. Now we need to be able to work out these reactions. If we're going to find our reaction at A, then we need our pivot at B. And if we're going to find our reaction at B, we need our pivot at A. Here we go. This is when you're going to use your pen as your amazing beam. So we have clockwise moments equals anti-clockwise moments. That's our clock. You remember we talked about direction the clock goes. If you get stuck in the exam, you can always watch the clock go around, but only for a few seconds. So what you're going to do is we'll put, if we're going to find our reaction at B, then we need to put our load down, our pivot point down at A. Now we can move our beam. You can see how our beam moves depending on what forces are acting. So you can see that reaction force B is going to want to push that beam up. Okay, so that's important. That means that that's an anti-clockwise moment. You can see the way that the pen is trying to move in an anti-clockwise direction. The forces that are acting down, the 45 Newton force is going to want to pull the beam down, and our UDL, the weight on the beam, is going to want to pull our pen down. Both of those are clockwise moments. Okay, so our clockwise moments will be 45, and this is all about A, so you must write pivot A, certainly until you get the hang of it. Everything then is from A. There's no reaction force at A because we're pivoting around it, so that's how we can negate that. Otherwise you have two variables you can't solve. So to start with, we have 45 newtons times 2 meters. If you put it in a bracket, then you'll know that that's that discrete forces required to calculate that moment. Then we're going to add that to the other clockwise moments. So the other one is the UDL force. So that is our 210, or 35 times 6 times 3, because it's 3 meters from A. Okay, that's the sum of all the clockwise moments. So that has to equal the forces acting in the other direction, which is RFB, which of course is what we want to find, and that is multiplied by the whole length of the beam to A, which is 6 meters. Easy.